previous video, we learnt about multiplication of two complex numbers. In this session, let's look at division of a complex number by another. Before we move on to complex over complex, let's see an example of complex over real. Is 6 plus 9i divided by 3. This should be easy. We know that dividing a number by 3 is equivalent to multiplying by 1 over 3. Hence, dividing 6 plus 9i by 3 is equivalent to multiplying 6 plus 9i by 1 over 3. We get 6 over 3 plus 9i over 3. That will equal 2 plus 3i. So dividing a complex number by a real number is easy. How about dividing a complex number by an imaginary number? Say 6 plus 9i over 4i. Before we solve this, let's understand what 1 over I means. Not very comfortable having I in the denominator. So how can we get rid of it? It's easy. We can multiply the numerator and the denominator by I. That gives us I over I squared. And I squared is nothing but negative 1. And I over negative 1 is nothing but negative I. So 1 over I is equal to negative I. Now let's proceed with the problem. Dividing 6 plus 9i by 4i is equivalent to multiplying 6 plus 9i with 1 by 4i. So this will give us 6 over 4i plus 9i over 4i. As we saw that 1 over I is negative I, this can be written as negative 6i over 4 plus 9i over 4i. Simplifying this will give us negative 3i over 2 plus 9 over 4. As we write a complex number with the real number first, this is 9 over 4 minus 3i by 2. So dividing 6 plus 9i by 3 gives us 2 plus 3i. And dividing 6 plus 9i by 4i gives us 9 over 4 minus 3i by 2. Clearly, dividing a complex number by a real number or an imaginary number is quite easy. How about dividing 6 plus 9i by 3 minus 4i? This is a case of a complex number divided by a complex number. Is this easy? Before we go ahead with the solution, I want you to think about how we can approach this. Just give it a thought. Well, when I had seen a similar example in school, I had no idea how to proceed. So don't worry, this may not appear to be simple, but there is a way out. Just remember one thing in general. None of us like having I in the denominator. It just doesn't look perfect. So can we get rid of I in the denominator without changing the value of the overall expression? This was a big hint. Think about how we can proceed. Do you recall the discussion regarding complex conjugate numbers in our previous video? We had observed that multiplying a complex number a plus bi with its complex conjugate a minus bi resulted in a squared plus b squared, which is a real number. So to get rid of I in the denominator, we need to multiply it with its complex conjugate. And to keep the value of the fraction unchanged, we will also have to multiply the numerator with the same complex conjugate. So we multiply the numerator and the denominator by the complex conjugate of 3 minus 4i, which is 3 plus 4i. This makes the numerator as 6 plus 9i multiplied by 3 plus 4i and denominator as 3 minus 4i multiplied by 3 plus 4i. The numerator here becomes a classic case of multiplication of two complex numbers. And the denominator is a case of multiplication of complex conjugates. Let's simplify the numerator first. It will equal 6 plus 9i multiplied by 3 plus 6 plus 9i multiplied by 4i. This will give us 18 plus 27i and this gives us 24i plus 36 times i squared. That will be 24i minus 36. Hence, the numerator is addition of 18 plus 27i and 24i minus 36. Adding the real and the imaginary parts separately gives us negative 18 plus 51i. That's our numerator. Now let's move on to the denominator. The denominator is 3 minus 4i multiplied by 3 plus 4i, which is nothing but 3 squared plus 4 squared. 9 plus 16 equals 25. Hence, dividing 6 plus 9i by 3 minus 4i gives us negative 18 plus 51i divided by 25. That can be simplified to negative 18 by 25 plus 51i by 25. Let's review what we did very quickly. When we divide a complex number by another complex number, we multiply the numerator and the denominator with the complex conjugate of the denominator. That will help us eliminate I in the denominator. In the next video, we will solve another example based on division.